spill occurs, there are four main approaches: natural cleanup, containment and recovery, chemical dispersion, and shoreline cleanup. In many cases, a combination of all four will be required. This program deals with shoreline cleanup, the place where sea meets land, our planet's coastline, miles and miles of varied shoreline, from rocky cliffs to mangrove swamps. Each coastline will have a different character. Some will be desolate, some the home for wildlife and fisheries, and others the location for amenities or industry. From time to time, these shorelines may come under threat of oil spills. Attempts to deal with the oil at sea are seldom completely successful, and oil frequently reaches the shore. The appropriate response will depend largely on the type of coast, its geology, ecology, and its usage, social and economic. Given the limited availability of equipment and manpower, the protection and cleanup of all sites may not be possible, and priority areas must be identified. Knowledge of coastal currents, prevailing winds, and locations of sensitive areas will assist cleanup teams in making vital decisions in an emergency. Before an emergency occurs, contingency planning for shoreline cleanup and disposal of recovered material is essential. Consideration must be given to the type of substrate, access points, the potential mobility of equipment on the shoreline, and the sensitivity of different environments to shoreline cleanup at particular times of the year.
Coastal sensitivity maps and decision guides should be included in the oil spill contingency plan. This stylized map identifies the different types of substrate: sand, marsh, shingle, and so on. The areas of sensitivity, shellfish beds, bird reserves, water intake. The access points and suitability for machinery, such as front-end loaders and graders, and convenient routes to disposal sites. Decision guides drawn up as flowcharts are not only a practical guide, but enable teams to think through problems before an event.
All too often, plans have not been thought through, with detrimental results. Machinery deployed on inappropriate beach substrate and structure has hindered shoreline cleanup, and environments have been damaged through lack of understanding of their sensitivity. Shoreline cleanup is a messy, labor-intensive, but relatively straightforward job, and can be effective if the right techniques are applied in the right conditions. A well-organized team of prepared personnel, managed efficiently, can be highly successful. Poor organization can often result in wasted effort and further spreading of the pollution. Every oil spill brings with it new and different problems, and personnel should be willing to adapt their training to the real situation and be prepared to improvise when necessary. But it's important to have an established chain of command and an efficient organization to prevent confusion. The manual workforce will also need supervision at small group level. Good interaction between the various levels of the organization are essential to ensure that all will be motivated and feel that they are making a useful contribution to the cleanup. From an environmental point of view, sometimes the best thing to do with an oil-polluted coast is nothing. Oil on exposed shorelines, subject to vigorous wave action, will be removed rapidly. Sheltered areas are often more sensitive, and the oil may persist longer. But attempts at cleanup may cause further damage. In practice, it's not always possible to leave the oil alone. People's livelihood and pleasures often depend on the amenities and resources provided by beaches. And certain species of wildlife depend on uncontaminated coastal areas for their survival. The method of removal selected depends upon the type of oil, the degree of pollution, and the nature of the contaminated surface. Three levels can usually be recognized in the cleanup of shoreline contamination. The removal of heavy contamination and floating oil, the cleanup of moderate contamination, stranded oil and oiled beach materials, and the cleanup of lightly contaminated shorelines and removal of oily stains. Heavy contamination, a mass of oil at the water's edge or stranded on the beach. On tidal shorelines, it may be possible to concentrate the oil at the water's edge by flushing it off the rocks or stones into booms. To some extent, cleanup techniques will be determined by the access and availability of machinery and the substrate to be cleaned. Where there is vehicle access to the water's edge, oil can be collected using skimmers, pumps and vacuum units. Although large volumes of water may be collected, this can rapidly be separated from the oil and drained off. Temporary storage of collected oil in plastic-lined pits or portable tanks close to the worksite ensures that shoreline cleanup activities can proceed uninterrupted. Where access is difficult, manual cleanup may be the only alternative, requiring a good supply of unskilled labor. Manual cleanup of fluid oil can be made more manageable by adding sorbents, man-made or natural. Heavy-gauge plastic bags are useful for carrying oil and debris off the beach, but should not be used for storage for more than a few days, as they can deteriorate and leak. Removal of heavy contamination from pebble and shingle beaches is more difficult. The oil penetrates the spaces between the stones, and the poor load-bearing characteristics of these beaches inhibits the movement of vehicles. Soft substrates may also cause a problem for vehicles, and they are frequently unable to support the weight. The problem becomes worse when the vehicles are loaded. Whilst tracked vehicles can overcome this problem, they tend to mix the oil into the substrate and can cause damage to sand dunes. Where the beach surface supports heavy vehicles, such as graders and front-end loaders, efficient cleaning patterns should be established.
A grader should work down from the top of the beach, its blade set to skim just below the beach surface. The oil and sand is drawn by the grader parallel to the shoreline. The collected oil can then be picked up by front-end loaders. If loaders are used on their own, more sand is inevitably collected. Excessive removal of beach material may lead to severe coastal erosion and disposal problems. Excessive use of heavy equipment can also damage the beach structure, as well as being an inefficient use of resources.
Muddy shores, marshland and mangroves always create special problems when contaminated by oil. More often than not, the advice on cleanup is don't. Experience has shown that on many occasions, activities intended to clear pollution have resulted in more damage than the oil itself due to trampling and substrate erosion. Where circumstances dictate that the oil is to be removed, low-pressure water hoses can be used to flush the oil into open water for subsequent collection. This contamination is termed as moderate. On this type of beach, the best approach is cleaning by manual methods, using the front-end loaders to transport the collected material. Each gang, comprising no more than 10 people, works under a foreman, who is in turn responsible to the beach supervisor. The chain of command is efficient, but relaxed. This operation may take longer, but less uncontaminated sand will be removed, reducing the amount of material for disposal. Methodical cleanup is essential. Here, the beach is divided into strips and a path prepared for the tractor. The oil is gently swept into piles on either side. The tractor and trailer can now be moved adjacent to the oil without grinding it into the beach. Oil matted into vegetation is carefully lifted from the sand. The fork is skimmed along the surface to remove as little uncontaminated sand as possible. The oil, debris and sand is collected into a trailer for transport to a temporary storage site. This shingle beach is being cleaned by means of high-pressure water washing. The dislodged oil is flushed into a containment boom and removed using a belt skimmer. Once heavy concentrations of mobile oil have been removed, rocks, boulders and man-made structures which are inaccessible to the public or do not have an amenity value should be left to clean naturally. Where cleaning is deemed necessary, rocks can be washed down under high pressure using hot or cold water. The released oil should be recovered wherever possible. Dispersants can also be used. For best results, the dispersant should be thoroughly mixed into the oil or applied as a gel to provide maximum penetration of the oil. In some circumstances, high-pressure washing down with salt water may be necessary. After the main cleanup of sandy beaches has been completed, the substrate is likely to be discolored or contain small residual amounts. A final cleanup of the light contamination and the removal of oily stains may be necessary to restore the beach to its original condition. Dispersants can be used in advance of the incoming tide. On tidal sand beaches, the oil can be mixed with a greater volume of sand to accelerate weathering. Solid oil lumps may be removed by specialized machines which use vibrating or rotating screens.
As the cleanup progresses and the amount of contamination is reduced, the effort required to bring about further improvement rises sharply. A decision must therefore be made when to call a halt. Factors to be taken into account include the importance given to the area, the time of year, the potential for natural cleaning.
Whilst cleaning is going on, vast amounts of oily waste can accumulate. It's important not to neglect the problem of final disposal. Temporary storage allows time for selecting the appropriate disposal method. If possible, bulk oil should be stored separately from oily debris so that different options can be followed. The disposal option chosen will depend on the amount and type of oil and debris, the location of the spill, environmental and legal considerations, and the likely costs involved.
Where possible, reprocessing of the oil should be considered. There are several techniques for separating oil from water or sand, but weathering and contamination often makes this impractical. Stable water in oil emulsions can sometimes be broken by treating them with an emulsion-breaking chemical. Where there is no danger of affecting groundwater, heavily contaminated material can be disposed of at designated landfill sites or mixed with refuse. Lightly oiled material can be simply buried at the back of the beach, provided there is no risk of damage to vegetation or re-exposure. By mixing oiled sand with quicklime or other binding agents, it is possible to stabilize the material for land reclamation or road construction. Lightly oiled sand and seaweed can be spread on waste land. Application of fertilizers and regular plowing will increase the rate of biological decomposition of the oil. Small quantities of oily waste can be burnt in incinerators using auxiliary fuel. A good air supply is necessary to improve combustion and to reduce smoke.
Oil spills are fortunately not common occurrences, and few people will have gained first-hand experience of them. Simulated exercises are a valuable preparation for an emergency. Mistakes here are less costly and can be rectified by drawing up or amending the contingency plan. In a real spill, a high level of organization is required. A response team can then make the best use of their resources and see the benefits of their efforts.